we have here? A word problem, and in this video we will learn how to solve yet another word problem by translating as we read. This word problem falls under the category of equations with variables on two sides, and that'll just naturally happen as we translate this. Let's check it out. This says a music streaming service charges $9.99 per month and a $4.50 sign-up fee. I stopped there because to me that translates immediately to $9.99 for every month. That's multiplication per month. So right away I'm going to do $9.99 per month. I'm going to let m equal the number of months. So we'll see if that'll end up being our variable, but let me just start out with that. So $9.99 per month and a $4.50 sign-up fee. That's a one-time fee, so it's going to be plus $4.50. It then says another music streaming service charges $10.49 per month with a $1 sign-up fee. $10.49 times m per month, so that's $10.49 per month plus a $1 sign-up fee. I'm just going to write that as 1. After how many months will the services cost the same? Well, this is the cost of service 1, and this is the cost of service 2. We want to know when those costs are the same or when they are equal. So we set the costs equal to each other. And we're done. Rather than read the whole problem, then look back and translate it, we translate it as we read it. And if we needed to make some tweakings, some changes to our setup, we could have. Now, one thing that's very important is let's define what m stands for. So m is the number of months, and that's verified here in the question where it says after how many months will the services cost the same. So m is the thing we want to know. So m equals number of months. Some teachers will want you to actually write out the word number instead of the pound sign or the hashtag sign. Okay, so that's it. That's our setup. That's the most important part, because from here, all you're doing is solving out the equation that you've generated. Very cool. So let's do that knowing that we just did a great translation. So I'm going to join up the variables. I'm going to move 999m over to 1049m by subtracting 999m. So minus 9.99m. Do the same thing to both sides and be careful with your operations now. This cancels out, which is great. We're left with positive 4.50 is equal to 1049 minus 999 is 0.5 or 50 cents. So 0.5m plus 1. Then we're going to undo plus 1 by subtracting 1 from both sides. And that 450 minus 1, once we see that the 1's cancel, is 350. 3.5 is equal to 0.5m. I realize I'm dropping zeros here, but that's just to make this into an easier equation to solve. To undo 0.5 times m, I divide both sides by 0.5. And we're left with m is equal to 3.5 divided by 0.5, which is 7. Or it will take 7 months until the two services cost the same, at which point we know that the service that costs more per month is going to end up being more expensive than the service that had a bigger sign-up fee to start but costs less per month. Cool stuff! I hope that you rock this problem. It's all about the translation and then realizing once you translate, you're ready to rock and roll. Quick reminder, when you practice problems like this, practice 4 or 5 of them just defining your variable and setting up an equation. Do that consecutively, one right after the other. Then go back and solve the equations that you have. All right, what we have here is a classic word problem, and it is one that has challenged students for years and generations. We are going to make this easier than it has ever been before. Let's do it. So we're given a word problem when it says that a plane leaves an airport traveling at a constant speed of 400 miles per hour. A second plane leaves 1/2 hour later from the same airport traveling at a constant speed of 450 miles per hour. How much time until the second plane catches up to the first? Oh my goodness. So how do we handle that? Now this is one of those problems where I just need to read the whole thing out. It was pretty long. Now let's go back and actually translate it step by step like we do with all our word problems. A plane leaves an airport traveling at a constant speed of 400 miles per hour. Okay, so if we're leaving at 400 miles per hour and a second plane leaves later than that, and we want to know when they had basically met, right? So plane 1 goes like this, plane 2 leaves a little bit later, and we want to know when that second plane catches up with that first plane. So we want to know when their distances are the same. Oh, well, so if we want to know when the distance of plane 1, I'll call that D1, is equal to the distance of plane 2, I'll call that D2. Well, distance, when you're given rates, 400 miles an hour, 450 miles an hour, they're related with rate times time. So you basically have the rate times the time of plane 1 equals the rate times the time of plane 2. Well, let's figure out the expression for plane 1. Well, that would be 400 miles per hour times the time. So 400 times the amount of time, and we'll call time t. T equals the amount of time in hours. That's the distance plane 1 will travel, 400 miles for every hour t. So t equals the number of hours. So the second plane leaves a half hour later. Ooh, well, if plane 1 is traveling for t hours, that means that plane 2 is traveling for 1/2 hour less than t. So the rate of plane 2 we know is 450 miles per hour. But the time that plane 2 travels for is whatever this time is minus a half hour. Let's see if we can make some sense of that. So if plane 1 traveled for 3 hours, then plane 2 traveled for 3 hours minus a half hour. If plane 1 traveled for 6 hours, then plane 2 traveled for 6 hours minus a half hour. So if plane 1 travels for t hours, an unknown amount, plane 2 travels for t minus a half hour. Or 450 times the amount of time would give us the distance that plane travels. We know they're set equal because we want their distances to be the same. And that's it, folks. That's the setup. The idea that distances are equal, and we find distance with rate times time equals rate times time. The tough part also is understanding that it's the total time that plane 1 travels minus that half hour for the expression for the time for plane 2. Now all we have to do is solve it using our skills. Of course, I'm going to define what t is. Little t is the number of hours plane 1 travels. That's a long definition. And now let's solve it. So if we want to know how much time has elapsed until the second plane catches up to the first, we're going to do that from the time that plane 1 leaves, unless your problem that you have specifies how much time does plane 2 travel for. Then we would have to subtract a half hour at the end. Let's do this. So solving out the equation is the easy part. It was setting it up that's the tough part. So we'll celebrate now. We will distribute on the right side. 1, 2. So you get 450t. And I'm going to do a little bit of mental math here, peeps. We're doing 450 times negative 1/2. Well, that's going to be 1/2 times 450, or 450 divided by 2, which is 225. And I will copy down the 400t. Now all that's left is we are going to subtract 450 from both sides. So I will subtract 450t from both sides of the equation. Sweet. And we're left with negative 50 times t on the left side is equal to, that cancels, minus 225. Ooh. Last but not least, we're going to divide both sides by negative 50 to isolate t, the variable, which is the amount of time that plane 1 has traveled. The negative 50s cancel, and we are left with t is equivalent to 225 divided by 50, or negative divided by negative is a positive, and that's going to be 4.5 hours. All right, 225 divided by 50. Now, if the question asks how much time since plane 2 has left, you'd have to take the 4.5 hours and subtract a half hour to find that it was 4 hours since plane 2 left, because t is the amount of time since plane 1 left. There you have it, peeps, a classic challenging word problem translated as we read it after we kind of grasped what it was saying until we just took it to town and just rocked it. No problems at all. Hope you enjoyed it.